Hi everyone, and welcome to our video on the magnitude and direction of a vector. So if we have a vector and we know its magnitude, we can still measure an angle. Okay, so for ease, we'll say we've got a vector that puts us in quadrant 1, but it could be in any quadrant. But either way, we could say, well, if this is my vector v, I know that I can still make a right triangle. This would be the horizontal component, vertical component. So my vector v in component form, I'm saying is x comma y. And then we would know that its magnitude is using from our previous video, it is just Pythagorean's theorem, but the magnitude is the square root of the x component squared plus the y component squared, or horizontal component plus the y component squared. So that's Pythagorean's theorem getting used. And then we can say, well, I know there's an angle here, theta. And so then I can start using SOHCAHTOA. So let's put that to the side, and then we'll take what we want out of it. So SOHCAHTOA would tell us that sine of theta is equal to the opposite y over the, so I'm looking at it as a right triangle. The vector itself is v, but the length, I'm going to mark the length for now. So I'm looking at it as the geometric triangle with lengths involved. So that means it would be the magnitude of v as the hypotenuse. And then cosine, we can do something similar. Cosine of theta would be x over the magnitude of v. Now on both of these, I'm going to go ahead and solve them to where I can get y. Okay, so that just means multiply the absolute value of v over. And same deal with cosine. If I get x by itself, it would be multiply the absolute value of v, or the magnitude of v, over as such. So there's our x and y for this scenario. So what we currently have is if I want to find my vector in a different form, so looking at my first form with x comma y, well, I have x here and y here. I can sub those in. So I could say my x component is the magnitude of v cosine of theta, comma, magnitude of v sine theta. There we go. Okay, so we get two things out of this. One other thing that might be useful, I didn't deal with the tangent part, but just to have it, tangent of theta is y over x if we needed it. Okay, so that can help us find the angle theta. Okay, so that's how, so again, SOHCAHTOA and Pythagorean's theorem comes along, and now we've got these different notations that we can use. All right, so if we're writing our vector v in component form or in terms of I and j, so it's up to us. So I did component form for those. We can still make a sketch. So it says the magnitude is 50, but let's measure that angle first. So the angle of 120 puts us somewhere in quadrant 2. So there's the angle theta, 120 degrees. And then we see the length of it is 50. Okay, so if I want to put this in component form, I'm going to go straight to my big old bullet right here that I'm doing again. And I'm just going to sub those in. Okay, so the picture is there to make sure my signs are going to be good. But I can just go and plug those in. Let's write it one more time. So the magnitude of v cosine of theta, the magnitude of v sine theta. And so now let's plug those in. We've got the absolute of value, or the magnitude of v is 50, and then cosine of 120, comma, magnitude of v is still 50, sine of 120 degrees. There we are. Then it becomes a simplified problem with our unit circle, or if needed, calculator. So here we can do these without a calculator. We would have 50. Cosine of 120 is negative 1/2. And then comma 50. Sine of 120 is positive radical 3 over 2. And so then we'll simplify it. 50 and 2 divide, negative still in front, so negative 25, comma, 50 and 2 divide, 25 radical 3. There we go. Oop, I pushed a button, it went weird. Let me scroll. Okay, so my final answer is right there. And that's in component form. Again, if we want to, we can put it in terms of I and j. So negative 25i plus 25 radical 3j. Okay, so it's up to us which way you want to do it. So I'm going to box that too. Okay, so that's it. And notice the x-coordinate of our horizontal component is negative. So that, yeah, to the left, and then positive vertical component means I should go up. Yes, that's looking good. All right, and we could really verify it if we want to, because I do have, here's just the triangle of it. There's the vector. So it's saying this is 25 to the left, this is 25 radical 3. If I did Pythagorean's theorem here, so that one squared plus that one squared should equal that one squared. It will verify it. All right, otherwise, let's move on to number 2 here. Let's block that off a little bit. So I'm still going to sketch it just to the side. So 330 degrees is almost all the way around the unit circle, just to see it. And then so that is the 330 degrees. So that way I can see I'm in quadrant 4 to make sure my signs are going to be good. All right, so this time around, I'm going to use my same setup, but I'm going to do it in terms of I and j right away. So that would be the magnitude of v, cosine of theta, and then I, plus the magnitude of v, sine of theta, and then j. Okay, so this is, I'm doing the same thing, I'm just doing it in a different form. And now I'm going to plug those in. So the magnitude of v is 9, and then cosine of 330 degrees, I still just going to be attached at the end, plus v is 9, the magnitude of v is 9, and then sine of 330 degrees, and j again is just attached at the end. Okay, so now that it's set up like that, we will continue simplifying. 9 cosine of 330 is radical 3/2, and then I still attached, plus 9 sine of 330 is negative 1/2, and then j is attached. And so nothing really simplifies nicely here, but we would want to make sure our signs are correct and write this as a single fraction. So it's 9 radical 3 over 2i, and then minus 9 over 2j. All right, so there it is in terms of I and j. Still, if you prefer component form, just to put it to the side, 9 radical 3 over 2, comma, negative 9/2. Again, no i's and j's in this. Pointy parentheses in terms of I and j, no pointy parentheses. It is just an algebraic expression. Okay, so that's if we need to convert our v in component form, or convert it into component form. Okay, well, we can go backwards as well. Okay, so writing v in component form, we could also take our component form and write it in terms of a magnitude and direction. All right, so here we've got our w. I don't know, I'm rewriting my w. I don't need to right now. Let's sketch it. Okay, so I'm going to put that right here. So it's a positive x component, negative y component. They are the same numbers. So that means it is going to be a special triangle as such. All right, so but what we want to do is find the magnitude and direction. All right, so they told us that length and they told us that length. So it looks like I can use Pythagorean's theorem or the magnitude scenario to get our magnitude of w. So let's get the magnitude first. So the magnitude of the w would be the square root of the horizontal component, so 5 square root of 2 over 2 squared, plus the square of the vertical component, all under that big square root. And again, it comes straight from Pythagorean's theorem, so there's a, b, and c. So a squared plus b squared equals c squared. We're just changing letters and rewriting it. And then now we'll simplify this. Okay, so we've got the magnitude of w is our big square root. When we square this fraction, it would be 5 squared is 25. Radical 2 squared becomes 2. 2 squared down below is 4. And then plus, it's the same thing. So 25 times 2 over 4. And then we can simplify this a little bit. Adding these two fractions together, notice the 2 and the 4 would cancel a little bit. I'm going to do that right now. Okay, so it'd be 25 over 2 plus 25 over 2. That would be 25. Okay, so that is just the square root of 25. So it simplifies real nice. So 25 halves plus 25 halves is 50 over 2. And 50 over 2 becomes 25. So that means our magnitude is 5. Okay, so we've got that portion. Okay, so let me cloud it. Okay, and then the second step is to get the angle. Okay, so this is where I think the tangent formula will now help us. So tangent of theta is the vertical component over the horizontal component. So on our problem, let me put it one more step horizontal since I'm running a little out of room. Our vertical component is negative 5 radical 2 over 2. Our horizontal component is positive 5 radical 2 over 2. Well, these are the same two numbers divided, except one's negative, so that would simplify to be negative 1. And then we can use our unit circle. Tangent of theta equaling negative 1 is either in the third quadrant, or not third, second quadrant or fourth quadrant, right in the middle. So I want to choose the right one. Now they do, I was about to do radians. They usually do degrees with vectors. You could do radians if you want, but I'm going to do degrees. So if I'm right in the middle of quadrant 2, that's 135 degrees. If I'm right in the middle of quadrant 4, that would be 315 degrees. So I would want to choose the correct one. Well, based on my original picture, it looks like I'm in quadrant 4, so I should choose the 315 degrees. Okay, so there we go. So we have our answer. Now, the way that they write it is, so what I clouded is pretty much it. They just write them next to each other. So we do have the magnitude of W is 5, comma, angle is 315 degrees. Okay, so that's it. So that's how we can change them into magnitude and direction. All right, so number 2, let's go ahead and take care of that one as well. If we're doing that, let me put my sketch way over here to make sure I've got enough room. Okay, so negative 5 radical 6 and then down 5 radical 2 is something like that. All right, so again, I'm going to get the magnitude first. So our magnitude, number 2, I didn't label it. I'm going to label, there's the angle. Or they might say direction. Okay, so angle or direction. Sorry, squeezing that in. All right, so number 1, magnitude. We've got the magnitude of t is the square root of the horizontal component. Notice, don't put the I there, just the numerical part. So negative 5 radical 6 squared, and then always plus the vertical component, which would be negative 5 radical 2 squared. Again, no j put in there, just like I didn't put the pointy arrows in the first one that we did. There it is, where my arrow's kind of at. All right, anyway, now it's simplify. So keep it going. So we got the magnitude of t is, when we square this, it would be positive 25 times 6 plus positive 25 times 2. And then we'll continue simplifying this. We've got the magnitude of t is, okay, so 25 times 6 is 150. 25 times 2 is 50. So we've got the magnitude of t is the square root of 200. Now, the square root of 200 is something that we can simplify. It is 102. So I can do the square root of 100. That's 10. And then the 2's attached. Okay, so that's our magnitude. Okay, so again, I'm just going to kind of cloud it. Step 2 is the direction. That's where I would just use tangent of theta is y over x. Plugging those in. Let me do that also horizontal, one more step, and then we'll rewrite it. So negative 5 radical 2 over negative 5 radical 6. So the vertical component over the horizontal component. Let me actually keep this one more horizontal to simplify. Notice the 2 negatives would cancel and the 5's would cancel. I would be left with radical 2 over 6, I just made it one big fraction to show that this would simplify to be 1 over 3. Still simplifying. Square root of 1 is 1. Square root of 3 is still the square root of 3. And then I would rationalize. And that way we can now simplify it one next line and say this would be square root of 3 over 3. Okay, and so this one also does not require a calculator. If we did, we would do our inverse tangent. But tangent of theta equaling radical 3 over 3, that is in the first quadrant and the third quadrant. I want it in degrees again. It is where I would have 30 degrees or 210 degrees. All right, so those are the two angles, but again, I want to choose the correct one. Based on my initial picture, I would want the 210 because it looks like I'm in quadrant 3. All right, so now we've got it. So our magnitude of t is 10 radical 2, and our direction is 210 degrees. Okay, so converting our component form to magnitude and direction, I think is a little worse than vice versa. Okay, but either way, we can see how to do it. Okay, so if we need one, we can switch it back and forth. Okay, so that's our vectors. What we've got next is applying these. Okay, so thanks for watching. We'll do our applications in the next video. I'll see you then.